some problems based on trigonometric ratios. Remember one thing, if you are very good hold an algebra, solving the questions from trigonometry is very easy. So my advice is, before going to learn trigonometry, try to get complete hold on algebra, then come to trigonometry. Otherwise, you suffer a lot. Okay, come to the first question, one by one. The first question is sin A plus cos A times of 1 minus sin A cos A is equal to sin Q plus cos Q. Now, we have a tradition of proving identities of trigonometry. How? We take left hand side expression, we simplify it, at the end we get a right hand side. Or you take right hand side, simplify it, you get left hand side. Or take left hand side, simplify it, you get one expression. Take right hand side, simplify it, you get another expression, and these end parts are both the same. In these three ways you can show these trigonometric identities. Okay, now come to the first one. First one is sin A. We have to show sin A plus cos A times of 1 minus sin A cos A is equal to sin cubed A plus cos cubed A. Now one method is take left hand side, open the bracket, simplify, get right hand side. But here I want to use an algebraic identity. So left hand side. Left hand side, left LHS. Sin A plus cos A times of 1 minus sin A cos A. I focus on 1. I can write this 1 as sin square plus cos square A. So we have sin A plus cos A times 4. I am writing this 1 as sin square A plus cos square A because we have identity, and next one is minus sin A cos A. It looks like A plus B times of A square plus B square minus AB, and you know very well nothing but A cube plus B cube. We have identity algebra. Here A is equal to sin A, B is equal to cos B. Therefore, I get A cube plus B cube, sin cube A plus cos cube A, which is equal to RHS. I got it. Therefore, we have LHS is equal to RHS. Second question. Secant A plus cos A times secant A minus cos A is equal to tan square A plus sin square A. So prove that secant A plus cos A times of secant A minus cos A is equal to tan square A plus sin square A. As usual, I'll take left hand side. Proof. Left hand side is secant A plus cos A times secant A minus cos A. Now, here I can apply identity. A plus B times A minus B is equal to A square minus B square. Here my A is equal to secant A and B is equal to cos A. Therefore, I get secant square A minus cos square. Now, secant square A as 1 plus tan square A minus cos square A, I don't touch that one. Now, 1 minus cos square A, I make them as one pair. 1 minus cos square A and plus tan square A as is. So, we have 1 minus cos square A is nothing but sin square A and this is tan square A. So, in this way, we got right hand side. Therefore, LHS is equal to RHS. Third, tan A, prove that tan A by 1 minus cot A plus cot A by 1 minus tan is equal to secant A cosecant A plus 1. There are two methods are there. One method is, of course, as usual, take left hand side and simplify it. So, left hand side, proof. LHS tan A by 1 minus cot A plus cot A by 1 minus tan. One simple method, whenever you find tan and cot, convert it to sin and cos. Simplify, definitely you will get. Now in trigonometry we have this specialty. If you go on applying identities, definitely you get an answer at the end. And one may take 10 steps and one may take 20 steps. Some smart people can solve in 2 steps also. But definitely you will get answer if you apply proper identities. Okay, but examiner always prefers a smart way, not a downty work. Okay, take left hand side. So first we do, I convert this to sin and cos. So I have become tan A will become sin A by cos by 1 minus cos A by sin plus cos A by sin A by 1 minus sin A by cos A. Next, fourth question. Prove that secant power 4a minus secant square a is equal to tan power 4a plus tan square. As usual, we take left hand side. Left hand side, I have secant power 4a minus secant square. What I do, just I take secant square common factor. So secant square a, I will get secant square a minus 1. Now convert them into 10. How? Secant square a is equal to, we have secant square a is equal to 1 plus tan square a. And secant square a minus 1 is equal to tan square a. That's all. Now open the bracket. You have tan square a into 1, tan square a plus tan square a times tan square a, tan power 4a. Of course it is RHS. Hence 4. Fifth question, 1 upon cosecant a minus cot a minus 1 upon sin a is equal to 1 upon sin a minus 1 upon cosecant a plus cot. Proving this is same as, just interchange this cosecant a plus cot a here and 1 by sin A cos A that side. So you have this is same as or 1 by cosecant A minus cot A plus 1 by cosecant A plus cot A is equal to 1 by sin A plus 1 by sin A. Of course, this is 2 secant. Proving this is same as proving this. So now my new LHS is 1 by cosecant A minus cot A plus 1 by cosecant A plus cot A. Just take LCM and simplify so that I get cosecant A plus cot A plus cosecant A minus cot A upon cosecant A minus cot A times cosecant A plus cot A. So here I can cancel these two. I got cosecant A plus cosecant A to cosecant A by cosecant A minus cot A into cosecant A plus cot A minus B into A plus B. So we have A square minus B square. And of course, cosecant square A minus cot A is equal to 1. We have identity. So we have 2 cosecant A, which is equal to right hand. Now A left hand side. Tan A minus secant A plus 1. We have 2 to 3 method to solve this question, and one of the smart method is now I concentrate on 1 in the numerator. In the place of 1, I have identity in terms of secant A and tan A. What is that? Secant A, secant square A minus tan square A is equal to 1. So in the place of 1, substitute this. What do we get? So put 1 in the numerator as secant square A minus tan square A. So we can have secant A plus tan A minus secant square A minus tan square upon tan A minus secant A plus 1. Now this is A square minus B square in the form of identity. So I can write secant A minus tan A, secant A plus tan A, and in these two, secant A plus tan A is a common factor. So I take secant A plus tan A as a common factor. From the first one, I get 1 minus from this one, I get secant A minus tan A by tan A minus secant A plus 1. Now, if you observe carefully, this is 1 minus secant A plus tan A. This is 1 minus secant A plus tan A. So I can cancel these two. So I get secant A plus tan A. Convert it to sin and cos and take LCM. You will get 1 plus sin A by cos A, which is equal to my right hand side. State. Seventh question, sin alpha plus cosecant alpha whole square plus cos alpha plus secant alpha whole square is equal to tan square alpha plus cos square alpha plus f. Now, as usual, I will take left hand side is sin alpha plus cosecant alpha whole square cos alpha plus secant alpha whole square. Of course, you can convert this cosecant into 1 by sine, secant into 1 by cos. You can do that and blah blah. Instead of that, what I do, straight away I open the bracket by using a plus b whole square identity. So we have sine square alpha cosecant square alpha plus 2 sine alpha cosecant alpha plus cos square alpha plus cos square alpha secant square alpha plus 2 cos alpha into secant alpha. Here, if you add both of these two, you will get 1 plus sin alpha cosecant alpha. That product is 1 because they both are reciprocal to each other. The same way, cos alpha into secant alpha also equal to 1. So here you get a 2, you get a 2. So this is 2 plus 2 plus remaining secant square alpha plus secant square alpha. So here 1 plus 2, 5. I want my answer in terms of tan. So I can apply secant square in terms of tan square, cosecant square in terms of cot square. So I can do this is secant square alpha is 1 plus tan square alpha, and cosecant square is 1 plus cot square alpha. Therefore, I have 5 plus 1 plus 1, that is 7. And this is tan square alpha plus cot square alpha, which is nothing but right hand side, hence proof. Some more numerical questions. The first question is, express all other trigonometric ratios in terms of cosine. In the previous video I had done one question in this one. You have to express all trigonometric ratios in terms of the cosine. The best method is solution. 1. Solution. Very simple. You have to express all other 5 in terms of cosine. So let cos theta is equal to x for something. Okay, or x by 1. Immediately draw a right angle triangle. This is A, B, C. Let this angle is theta. So cos theta is adjacent side by hypotenuse. So this is x and this is 1. By using Pythagoras theorem, we get this as 1 minus x square. So we have a rectangle triangle and we have all the 3 sides. So the first one is sin theta. Sin theta is opposite side by hypotenuse. So root over 1 minus x square by 1. Now something simply put x is equal to cos theta. So we have 1 minus cos square theta. Now come to tan theta. Tan theta is equal to, and you have opposite side by adjacent side, that means root over 1 minus x square by x. Replace x by cos theta, you get 1 minus cos square theta by cos theta. Then come to cot theta. Cot theta is nothing but reciprocal of tan theta, so we get cos theta by root over 1 minus cos square theta. Then come to secant theta. Secant theta is just a reciprocal of cos theta, so we have 1 by cos theta. And finally, you have cosecant theta is 1 over, that means hypotenuse by opposite side, or 1 by under root of 1 minus cos square theta. So we could express sin, tan, cot, secant, cosecant in terms of cos theta only. Sine of an acute angle is 1 by 4. Find the numerical values of other trigonometric ratios. Second question and first question both are same. Now what is given here? Let's second question. Let for some angle theta, certain angle theta. What is given? Given sin theta is equal to 1 by 4. And you have to find other trigonometric values. Very simple. Draw a right angle triangle. This corner angle is theta. So sin theta is 1 over 4. That means 1. Opposite side 4. And whereas this is nothing but 16 minus 1 is equal to root 15. Now I have all lengths of the sides of the triangle, so I can find very easily. Remaining is we have cos theta. Cos theta is adjacent side by hypotenuse root 15 by 4. Tan theta opposite side by adjacent side 1 by root 15. Next, tan theta is equal to reciprocal of cot theta. Next one, secant theta, reciprocal of cos theta. Next, cosecant theta, a reciprocal of sin theta. 4 by 1. Now, I am doing the fourth question. Tan theta is 1 by root over 7. Find value of cosecant square theta minus secant square theta by cosecant square theta plus secant square theta. Now just like 1, 2, 3, I can do this question also by drawing right angle triangle, but I don't want to do that. I want to use identities. So what we need to do, cosecant square theta, we need to find cosecant square theta minus secant square theta by cosecant square theta plus secant square theta. By using identities, I will convert this cosecant square and secant square in terms of tan theta and cot theta. Cosecant square theta is nothing but 1 plus cot square theta minus, and this is nothing but 1 plus tan square theta. Same thing for denominator also. 1 plus cos square theta plus 1 plus tan square theta. Or I can cancel this 1 and 1. So I have cos square theta minus tan square theta over 2 plus cos square theta plus tan square theta. Now I can substitute. Tan theta is 1 by root 7. Therefore cot theta will be root 7 because tan and cot are reciprocal to each other. Therefore my cot square theta will become 7. And tan square theta is 1 by 7 by this is 2 plus 7 plus 1 by 7. Now you have to assume. Next one, 6. Tan theta plus secant theta is equal to 1.5 or 35. You have hand side. Tan theta plus secant theta is equal to 3 by 2. Then find tan theta. So you have so many methods. You have squaring on both sides, or substituting sin, tan and secant terms of 1 by sin and cos. A lot of things are there, but I'll use one identity to solve this question. What is that? We have secant theta minus tan theta is equal to 1 over secant theta plus tan theta. These two are reciprocals to each other. So I'll use this identity. Therefore, we have secant theta plus tan theta is equal to 3 over 2. Taking secant theta minus tan theta is 2 over 3.